let's look at some linear models and base this on trends in some data. So below is a scatter plot of data based on the average Math 123 grades for 302 students and the number of class sessions they missed. So before we even really look at the questions, let's focus on the graph. So you can see the x-axis is the number of absences. So how many classes did a student miss? And then the vertical axis here is the overall course score from 0 to 100. All right, let's look at number 1. The independent variable are all the values found along the x-axis, which is the horizontal, as I mentioned here. What is the independent variable of this graph? Well, I guess I already kind of answered that for you. So the independent variable is the number of absences. Now, when we think of independent and dependent variables, it's important to kind of understand what makes this independent. So if you think about the relationship between a course score and the number of absences, if you think about, well, what comes first? Your overall course score comes at the end, right? So there's a lot of different pieces that impact it. You know, how many assignments you do, how many classes you attend, all those kind of things. So the number of absences are a factor that contribute to the overall course score. So it's independent because it impacts other things, right? Your absence in class impacts your course grade. So it impacts other things. That makes it independent. If, let's move on to number 2, the dependent variable, right? The dependent variable is our vertical or our y-axis. So the dependent variable is our overall course score. Now, when we think about like what makes this dependent, the overall course score depends on the number of absences. At least that's what this graph tells us. The more absences you have, the lower your course score, right? That's what this kind of shows. And if I think about my years of being an instructor, that's kind of true. The students who show up and do what they need to do tend to perform better overall. Number 3, data is graphed by plotting ordered pairs, often written as x, y. So they have the independent variable first and the dependent variable second. Let's interpret the ordered pair provided on the graph. Be sure to include what each value represents. We see the ordered pair given is 5, 61. The x, remember, is the number of absences. So this ordered pair tells us there are 5 absences. And the y value is 61. That means the overall course score is 61. This ordered pair together tells us for this particular student, they missed 5 classes and overall got a 61 in the course. That's what this ordered pair represents. A positive trend occurs when one variable increases and the other variable also increases. So when the 2 variables do the same thing, whether they both increase or both decrease, as long as they are the same, you have a positive trend. A negative trend occurs when one variable increases and the other variable decreases. Using the names of the 2 variables from the scatter plot, describe the kind of trend. Let's look at each piece. So when we look at these, the dots, okay, that's kind of what we're looking at here. But as we go from left to right, the number of absences increases. And if we go from left to right, what do you notice about the scores? They go down. So the course scores decrease. So because we have an increase and a decrease, we have a negative trend. So we would say there's a negative trend because as the number of absences increase, the overall course score decreases. And you just look at the dots on your graph. What is happening to them? As I move left to right, the absences get bigger. As I move left to right, my course scores get smaller. So we have an increase and a decrease. Therefore, we have a negative trend. Based on this data, what course grade would you predict for a student who missed 12 class sessions? So we find 12. we go up, and it's about right here. So if we look over to the vertical, it's about halfway, so I would say it's about a 30. So for a student who misses 12 class sessions, they can expect to get around a 30 in the course. But what are some limitations on this? Now, there's so many different things. One, this is, remember, 302 students are in this, and these are the average course scores. So how many students missed 12 classes? We don't know. This could be one student. And if that's one student, is this really, good data? You need a decent sample size, and 302 is a decent sample size, but how many actually missed 12 classes? We don't know. Also, were there other circumstances for this student? So maybe they missed 12 classes, sure, but maybe also, maybe this is the first math class they've ever taken. And so this was all brand new, and it just makes it harder. It's possible. What if this student was in a car accident, and that's why they missed 12 classes, and when they came back, they were still in a lot of pain, and they had a lot of issues and complications, and that caused issues, right? So there just could be so many different factors that could also impact that we don't necessarily know if it was just the missed classes or if there were other things that also contributed to that average course score of 30. So just some things to think about.